Okay, this was assigned a little while back for you to read the article for Accumulation of Change, but we're going to do notes on it because it can be a little confusing with the units. And so we're going to just go back over it so that then we can talk about what, like the calculus interpretation of graphs of accumulation functions means. Okay, so let's start with an example. And these are not in your handout, so you're going to have to handwrite your notes. Sorry about that. Okay, suppose a tank is being filled at a constant rate of 5 liters per minute. What is the volume of water in the tank after 4 minutes? Okay, this has a constant rate, so this is not calculus. That's the whole point of calculus, is that it's variable, rates. Okay, so, but let's just think about it. Well, if it's 5 liters per minute and you go 4 minutes, then your volume is 5 liters per minute times 4 minutes. Now your minutes cancel and you get your volume of 20 liters. Okay? That's not the point of this. I mean, we could totally do that back in like 7th grade or something, or 6th grade, who knows. Okay, but the point of it is let's graph it. So let's say that we're going to graph R of t, which is just 5 liters per minute. Okay. All right. Well, there's not even a t in here, so this is just a constant function, y equals 5. And so I'm going to graph that. 5, 4, 3, 2, 1. Ew, I don't want to graph there, so I'm going to go here. 1, 2, 3, 4, 5. There it is. And then, okay, and then I need to go to 4. All right, and then there's my rate function. This is R of t, right? So if I do it at 4, then notice this is just a rectangle, and its length times width is 20. Okay, so the area under the curve is the accumulation of the rate, okay, of the top units, okay? So it's the accumulation of liters. That's what accumulation means. All right, so in other words, we could say that the volume is the integral from 0 to 4 of 5 dt. And if you do that, now use the power rule, what do we get? We get 5t, and then evaluate it from 0 to 4, which is 5 times 4, which is 20. Okay, now that when you first did this, you did not have definite integrals knowledge, so it was really just an understanding of how to do the accumulation of the picture, okay? All right, but seeing he's using calculus, you also get it. All right, now obviously that would be silly to do calculus with this, so let's do another example. Let's suppose that same tank, okay, so the tank is being filled at a rate of R of t equals 6 sine of 0.3t liters per minute. Okay? And now I want to know, what's the volume after 4 minutes? Okay? All right, so now we're going to need to use calculus because it's going to, when you graph this, it's going to be a curve, a sine curve. And I don't know the area under that because I can't use circles or triangles or squares or any of those things because a sine curve is not a perfect circle. Okay. It's more of an egg shape. So I have to use integral calculus. So I'm going to say, well, the volume is from 0 to 4 of 6 sine of 0.3 t dt. And here we use t's just because it's time. I mean, you could use x and dx. It doesn't matter. Okay? All right, and then you just put this into your calculator. If you do not have a calculator, all right, there is desmos.com, which does scientific calculator. It does four-function calculator. It does graphing. If you're having trouble with that, let me know if you don't have a calculator at home, and we will get one to you, okay? If you would rather have one just to key in, all right? Because I would really like for you to practice with these. So if you don't have one, a handheld calculator at home, even though we're using Desmos, I'd really rather you have a handheld one so that you can keep practicing for your exam. So just let me know. Please email me. Okay. So anyway, we type this into the calculator, and we get 12.753 liters per minute. Please take a moment and make sure that you can type that into your calculator and get that right now. So pause it. Make sure you can get that on your own in your calculator. If you can't, please email me, and I will set up a time to help you individually with your calculator. Okay, let's see. So, by the way, if there was already water in the tank, okay, that would not, the integrand would not represent the actual volume. It is only the accumulation. For instance, if the tank already had 7 liters in it, then V would equal 7 plus 0 to 4 of 6 sine of 0.3 t dt, which would be approximately 19.753 liters per minute. Okay? So it's not the actual, it's just the accumulation. All right, let's do another example. These are more, the rest of these are just about units, not so much doing antiderivatives, okay? All right, if R of t is grams per day, what are the units of 0 to 8 R of t dt? Okay, well, R is the rate, and it's grams per day, so then when you do the antiderivative of grams per day, you just get grams. All right, oh, at the top of your paper, please put, well, I'm going to put AB, but you don't have to put that part. I just have got to keep track of a whole bunch of notes, but then put today's date, which is 3/17/20. Okay. All right, continuing on. Okay, another example. If R of t is in kilometers per hour, what does 2 to 3 R of t dt equals 6 mean? Okay, well, that means that in the third hour, because you go from 0, zeros are always our beginning, so 0 to 1, 1 to 2, 2 to 3, so that's the third hour. So it means that in the third hour, 6 what? Kilometers were accumulated. Meaning like driven, walked, run, whatever the thing is. Driven, walked, etc. Okay, another one. If R of t is thousands of dollars per month, what does 3 plus 1 to 5 R of t dt mean? Okay, it means that what? What does this mean right here? That is that we started with $3,000. And then in months 1 to 2, 2 to 3, 3 to 4, 4 to 5, in the next 4 months, so between months 1 and 5, okay, then it accumulated what? 19, 18. Oh, oops, I forgot that. Equals 19. Sorry. You should, if you're writing in pencil, erase and write that. Okay, then 19, 18, 17, 16. Then it means we accumulated $16,000 more dollars. Okay, so we started with $3,000. Okay, then accumulated, well, 19 minus 3. So 19, 18, 17, 16,000 more in the months 1 through 5. Okay. So this one wouldn't start with 0, but yeah, 0 to 1, 1 to 2, yeah. So, okay, at the end of the 5th month, okay. Okay. All right, one more. K of t is the amount of ketchup in kilograms produced in t hours. What does 0 to 4 k prime of t dt mean? Okay, so let's reason through it. K of t is kilograms, the amount of ketchup in kilograms. Okay, so k prime of t is kilograms per hour, which means it's just a rate. So then the antiderivative of k prime of t dt, all right, from 0 to 4 is just kilograms, because the antiderivative of a rate is just the measurement, okay? In other words, that's just back to k of t. K of t is the antiderivative of the derivative, right? Okay, just like the fundamental theorem of calculus, the antiderivative of the derivative, okay? So it's just back to k of t, but it's an accumulation. So k of t equals that is kilograms accumulated. Okay, so I think we're ready to answer it. It is the kilograms produced in the first 4 hours.